Take a left at the big oak tree, go past the red barn, and if you hit the gas station, you've gone too far. Finding a new location based on vague verbal directions is a universal frustration. To solve this, early humans developed a highly effective technological workaround, the flat map. By establishing fixed cardinal directions, north, south, east, and west, the map provides a permanent method of orienting yourself, regardless of which way you happen to be facing on the street. A map's legend acts as a translator. It takes complex physical obstacles like mountains and rivers and turns them into simple, readable symbols. By including a scale bar, the map allows you to calculate real-world distances, converting a few inches of paper into actual kilometers on the ground. Maps are essentially translation devices. They take a chaotic, massive, three-dimensional environment and shrink it down into a highly readable, two-dimensional instruction manual. For navigating extreme natural terrain, physical maps are the tool of choice. They represent intense vertical realities, like the jagged peaks of the Himalayas. Political maps, on the other hand, map out human-made borders and cities, while thematic maps overlay specific datasets, tracking everything from annual rainfall to population density. But flat maps contain a fatal mathematical flaw. They cannot accurately represent the entire planet at once, without lying to the viewer. It is geometrically impossible to peel an orange and lay its skin perfectly flat. To force a spherical world onto a rectangular sheet of paper, the land masses near the top and bottom must stretch and tear, severely distorting their true shape and size. Flat maps work perfectly well for navigating a local city or a single country, but mastering the geography of the whole Earth requires a tool that mimics its true spherical reality. The globe solves the distortion problem entirely. By replicating the actual shape of the planet, it preserves true-to-life proportions and accurate sizes for every continent and ocean. However, globes introduce a different problem. Try giving someone precise directions across a vast, featureless ocean on a smooth sphere. Without street signs or landmarks, there is no frame of reference. This diagram shows a wireframe grid wrapping around a spinning 3D Earth. This grid is humanity's mathematical overlay, designed to solve the problem of navigating empty space. We start by drawing horizontal rings around the planet. These are lines of latitude. They originate from the 0-degree equator and measure distance north and south, stacking all the way up to the poles. Next, we draw vertical arcs from pole to pole. These are lines of longitude. They originate from the 0-degree prime meridian to measure distance east and west. When these horizontal and vertical lines intersect, they create exact coordinates. By combining a latitude and a longitude, we can pinpoint specific locations like Delhi and Mumbai anywhere on the sphere. By trapping the Earth in an intersecting web of imaginary lines, we assigned every single inch of the planet a unique mathematical address. The global grid reveals the physical behavior of the planet itself. This diagram illustrates how solar radiation hits the Earth. Because the Earth is a sphere, the sun's rays hit the equator directly, delivering intense heat. But those same rays strike the curved poles at a dispersed, weaker angle, bouncing off and leaving the region cold. Latitude lines perfectly map out this heat distribution. The area tightly straddling the equator forms the torrid zone, defined by its hot tropical climate. As your latitude increases and you move further from the equator, the direct sunlight fades. You enter the moderate temperate zones and eventually reach the freezing frigid zones at the poles. A location's horizontal position on the grid dictates its environment. Even without a photograph, knowing the latitude tells you exactly which temperature zone you're standing in. While horizontal lines delineate the weather, vertical lines delineate the time. This animation shows a top-down view of the Earth rotating from the North Pole. The math of planetary rotation is exact. The Earth completes a 360-degree spin every 24 hours. Divide 360 by 24, and you find that every 15 degrees of longitude equals exactly 1 hour of solar time. To measure this, we needed a starting point. We agreed to set 0 degrees longitude at the Royal Observatory in Greenwich, establishing Greenwich Mean Time as the world's 0-hour starting line. Before this grid, every town set its own clocks by the local sun, causing massive scheduling chaos as soon as railroads were invented. Standard time zones solved this by grouping large vertical sections of the globe into unified hours. India, despite its width, utilizes a single standard meridian to unify the entire country. Indian Standard Time operates exactly 5.5 hours ahead of Greenwich Mean Time. And if you travel all the way to roughly 180 degrees longitude, you hit the international date line. Because you've added or subtracted 12 hours from Greenwich, crossing this specific line forces you to step forward or backward into a different calendar day. Longitude ultimately solved the chaos of local daylight. It synchronized scattered human populations into a single, structured 24-hour global clock. For centuries, calculating your exact position on this grid required staring at the stars, mastering complex mathematics, and surviving dangerous ocean voyages. Today, the Global Positioning System, or GPS, makes that exact mathematical process automatic and instantaneous. A network of complex satellites now manages this grid from orbit, maintaining the same lines established centuries ago. These satellites continuously track your location, beaming exact coordinate data straight through the atmosphere and into the digital maps living inside your smartphone. We started out with a very simple local problem, trying to find our way around our own neighborhoods. To solve it, we built a spectacular invisible web in space that connects the entire world.